Okay, so this is a screencast for a boilerplate for three.js. You can find the project at this URL, so github.com Jerome-Etienne 3.js boilerplate, and you reach this page. So what is a boilerplate for three.js? It's a template to get you started. You download it and modify it until it fits your needs. It's a fast way to create a clean project with three.js. It avoids repetitive tasks and include various good practice and compatibility feature. So this is the README. What happened on the screen? You get something like that on the screen, which is not that impressive. But it works on desktop and mobile. You handle touch event, you handle resizing, you can do full screen API. If you press F, you do full screen, or if you press P, you do a screenshot. It's cool for your friends. So the topic of this particular screencast is to walk you through the various files, what are their purpose, a short introduction. Let's see how it happened. Alright, so we got this. How do you get to use it? You basically download it. Here you have a git clone of the repository, and you start modifying the files until you like them. You can download here as well. Whatever you want, both works. So let's get started. You got a directory structure, so various placeholder directories that I use. This one obviously CSS is for CSS, image is for image, JS is for JS, and vendor is for external dependency. We have stuff like three.js, obviously 3x on this one, which is gonna be removed soon. So 3.js obviously because we do 3.js boilerplate, and 3x is to get all the small features that I added. Alright, so we have all the four directory here. We have a very small Makefile which is not that useful, but this one is to start a server, a web server. That's an easy way to start a web server. If you do make server, then you're gonna deliver the content of this world directory under the port 8000, so you can easily reach your content without having to configure your own web server. Nothing forces you to use it. So we have seen the four directories, the Makefile, readme.markdown is usual GitHub stuff. You see the content here. Revision contain a single ASCII number. For the current revision of this project, as it is computer stuff, we like to start at 0. So this is current revision 0. Okay, so you have seen everything. So yeah, maybe CSS, very basic CSS that you can most likely remove. You can probably keep the body. All the info stuff in the CSS is, you see those little text here on top, on here. This is the info stuff. If you want to keep it, you can, but that's not that useful either. So you can most likely remove it. Okay, so we have seen the CSS. Image is empty. Because of Git, I have to put some placeholder, so I put get ignore in this. JS is empty, so get ignore as well. On vendor is three.js 3x on pan control. Okay, this is the camera control. We have seen README, we have seen the README markdown, the revision. Let's see the meat. What is the important stuff in there? Okay, let's put the normal size. And let's me walk you through index.html. So it's an absolutely normal HTML file. First, so HTML, you got the head of the HTML, the title, the meta, the meta because it's useful. The meta name viewport on this line here is done to get working on mobile and this kind of things. Okay, so we have this. Now let's see all the JS that we include. Obviously, we include three.js, detector.js. Detector.js is something to see the various capabilities of your computer. Think of it like a very small modernizer, but very small, don't do much. In our case, it's mostly interesting because it detects the presence, the availability of WebGL or not. We're gonna see how to use it later. So request animation frame, this is a cool thing. You have a link here. And this is useful to have smooth animation inside the browser. I will not try to explain to you what is it more deeply. Just go this link and you're gonna see. Stat.js is a view meter, let's say, to get the performance of your page. You see it here, you can click here, so you got the FPS, for example, 59, 60. Here you got the exact same thing, but in milliseconds, not that useful. And you can have some memory usage with some special command lines that I don't remember right now, but I'm sure if you go at this link, you're gonna see how it happened, and that's gonna be cool. After that, we include some 3x helper, one for screenshot, one for full screen, and one for window resize. Okay, here we have a special camera control in order to have good compatibility, especially with touch event. And this last one is the very simple CSS that we have seen before. So let me maybe, well, no, that's gonna be cool. That's very simple CSS. You can probably keep only the one for the body, and after that you discard all the rest for the info if you don't need the info. So we have seen the head, all this head. Here we have seen the meta, all the script, on the CSS. Now let's see more of the let's say the body. So this div here with an ID container will contain the Canva used by three.js. Yes, it's a Canva, even if you render in WebGL, it's a Canva. Don't ask. Here, this is the HTML for the info on top. So you got the info. This one is the one completely on top. So learning3.js, Boilerplate for three.js. You can see that learning3.js, the link here. Boilerplate for three.js. So this is this info here. The inline doc here is this one here. And that's it. So you got the info here. We have seen the markup, the HTML markup. Let's see about our JavaScript. And that's going to be the end. Okay, so you start with JavaScript. We declare some global. And we start the actual code. So we call the function init. If init returns some non-false value, let me repeat, false value or falsy value, we're going to start the animation. Thus, init can fail. It's quite important because sometimes you may not have WebGL and require it, and or whatever reason your initialization may fail. Then you start the animation. Alright. After that, we have only two functions: init or animate. And another one render. Okay, so what is the init? It inits the scene, the 3D scenes that we're gonna build. First, we try to see if WebGL is supported, so we use the detector.js script that we included before. This one. Okay, so if WebGL is supported, we init the WebGL renderer. So with anti-alias and preserve drawing buffer. Anti-alias is cool because it gives you a smoother output on the screen. Or preserve drawing buffer, it's a weird name to say, I want to do screencast. Screenshot, my bad. Screenshot with 2 data URL. On this one is to give the background color of the renderer. So we pick this one, that's sort of gray that you see here. Okay, so if WebGL is supported, sorry, if WebGL is supported, edit WebGL renderer. After that, we have three lines which are commented. Uncomment them if WebGL is required. So this detector add WebGL message is something which gonna display some kind of small message, something like you don't support WebGL and it's useful, it is important, it is required, go here to get WebGL, blah blah blah. Warning message. It's quite important to put it because else people coming to your site without WebGL will just think that the site failed and we have no chance of fixing the problem. Okay, in the boilerplate itself we play it quite safe, and if WebGL is not supported, we do the Canva renderer with a wonderful fault just here. I'm gonna fix it. Alright, so after this if, we have a renderer, hopefully. We set the size, we put it full screen, full window. So we set the size with the inner width and inner height of the window. After all that, we put the renderer DOM element inside the container. So the renderer DOM element, I will never succeed, man. The renderer DOM element, we put that inside the container. We have seen the container just here. So this gonna include the renderer DOM element. So now we have a renderer, we added the renderer into the DOM. We add stat.js. So we instantiate the object, position the object on the screen, on the page, and add it to the DOM of the page. So you can see position absolute on DOM 0 pixel. So because of that, it's gonna be stuck on the left bottom. And after that, that's cool. Okay, after that we create the scene. The scene is like the very big object which contains all the information that you need for three.js. And when you render in three.js, you render a scene. So we create the scene, currently it's empty. After that we create the camera. The camera is, the position of the camera is, think of it really like a camera is where is your point of view. There is a scene and you move inside this scene. When I say you, I mean the camera move inside the scene. So we initialize it. In this case we use perspective camera because that's a usual one with a perspective. We initialize it. I will not explain to you the parameter of camera, but this is the FOV, this is the aspect, the far, the near, and the far. Okay, so we have initialized the camera. Now we put the camera at a given position inside the scene. So camera position set on XYZ, so 005. That means that, sorry. That means that the stuff is like here. And after that we add the camera to the scene. But the camera in itself has to move. You see when I move the mouse, in fact the camera moves around the object is staying still. So we need something called the camera control for that. So we initialize the camera control with the drag pad control. The drag pad control is this type of control. You can look at the source. It's pretty easy to do. So we have done some DOM stuff, initialize the renderer, and the renderer to the DOM. After that we initialize chat, add it to the DOM, initialize the scene, initialize the camera control. We are pretty in good shape already. Here we add 3 features which I consider best practice. First, give you the ability to make screenshot by default. When you're here, I type P. Well, okay, in full screen it doesn't make much, but so without the full screen, I'm here, I type P, and suddenly I take a screenshot and open a window with it, with a data URL that you see here. Obviously it's ugly, but it works pretty well, no need for servers, and that's enough for you to share with your friends. Quite useful, the screenshot, when you want to debug, you want to show what is on your screen to the developers, so these kind of things. Or simply to brag about it, to say, look, this is very nice, so you share the image. Okay, so this is the purpose of the screenshot. Here, after that, we allow full screen. Full screen is a new API from HTML5. It's quite cool because from here, you press F and suddenly you enter the full screen. It's useful when you're embedded in a small page. You can take the full screen, so you have no distraction on left, no advertisement to bother you or stuff like that. It's quite cool, and you have a bigger display as well. That's useful. That may be useful at least. Okay, and after that we handle window resize, in which you put renderer and camera. This is quite cool, obviously, window resize, because it works when you resize the window, obviously. So you may say, yeah, that's not too useful, I never resize a window, blah blah blah. First, it's not too nice, but in fact window resize, my bad, is extremely useful when, for example, when I do full screen, it's important to resize, right? Here he asks for permission, so you say hello, let's say. Okay, so where were we? So let's come back to the source. Here we have the detector to know if WebGL is supported. If WebGL is supported, you will need WebGL renderer, else you do Canva renderer. You add the whole thing to the DOM. After that, you need on stat and put it to the DOM. You need the scene. You need the camera. You need the control camera. Add various features with screenshot, full screen, on camera, on the window size. And that's it for the initialization. After that, I just put a small object here, which is purely random. This is where you have to put your own stuff. For example, I put a torus, which is this shape. Believe it or not, it's called a torus. Various parameters of the torus. The material is how the my bad, how the object will look like. The geometry is like the shape, or the material is it red? Is it shiny? Is it plant? Stuff like that. This is the material. After that, we unify both. It's something that we call the mesh. So we create the mesh with the geometry and the material, and add the whole thing on the scene. And this is this object. So the normal is this weirdo color, and the torus is the torus. And as you can see, that's the end of the init function. This function do a complete init of three.js. And If the init succeed, we go to the animate function. Let's go there. The animate function is a function which are run during the animation loop. So you most likely you will run that at something like 60 FPS, 30 FPS, these kind of things. As you can see here, currently it's running at 60 FPS. So you go here, this function is called 60 times per second. Request animation frame animate is the things in order to loop. You loop on 1 minute next time. I can do some animation on this computer. After ending the loop, you come and call the function render. This function render is here. It does two things at the moment. This function is there to render the scene in itself. So first you update the camera control, something like you move the mouse, I'm gonna update the camera position. You see I move the mouse here, here, every time the camera is moving with me. So I update the camera control. On this function is this function, this line is one telling, well, I can't say that. Here you actually render the scene with this line. This is the main line, let's say. This is the one doing all the WebGL inside, all the stuff. So this function renders the scene only once, but renders the scene. That's already good. So you come back to animate. We have the animate function, which is called during the animation loop. You got request animation frame, so this is looping. Render, so during each iteration of the loop, you're gonna render the scene, and you update the stat, obviously. Else, this stuff will not be updated. So you need to update it. And I believe that's it. I was looking for something to say, and apparently not. So that's a pretty long screencast. It was mostly improvisation. I hope it's okay. We will see. See ya, guys. I will likely do more in the future. More screencasts, I mean.